What's up, engineers? Welcome sa part 5 ng ating Thermodynamics lecture series. Alright, okay, engineers, mag-ingay! Alright, ayan, thank you. Okay, ayan, so, game! Let's do this! Okay, so for our part 5, ano po ba yung una nating titirahin? Game! So, first we have entropy. Ayan. So, ano po bang meron kay entropy? So, absolute entropy is a measure of the energy that is no longer available to perform useful work within the current environment. It is the measure of randomness or disorder of the system. Okay. So, si entropy pala ay siya yung energy na hindi na natin magagamit into useful work. Okay? So, ano pa bang mahalagang tandaan kay entropy? Yan po yung last statement, no. Madalas din po siya lumalabas, no, the measure of randomness or disorder of the system. So yan po yung kailangan nating tandaan. Okay. Ayan. So, formula ng ating entropy is Q over temperature or the heat all over temperature in Kelvin. And since that is the formula, the ratio of energy and temperature, the unit of entropy is joule per Kelvin. So, ganun lang po kasimple. Alright? Yes, sir. So, again, entropy is energy na hindi na magagamit. No. So, ibig sabihin, wasted energy. Next. Internal energy. The energy stored within the body, it is the sum of the kinetic energies of all its constituent particles plus the sum of all the potential energies of interaction among these particles. So, again, energy, internal energy is the stored energy within the body. Okay. So, ito yung hindi pa naiilabas. Okay? So, hindi siya yung nasayang na at hindi rin siya yung useful. Siya yung nasa pa lang, nasa loob pa lang. Okay? So, waiting na mailabas siya. So, it can be pwede siya maging not useful or pwede din siya maging useful energy. Okay. Next. Ayan. So, enthalpy na tayo. So, the heat energy transferred to a substance at a constant pressure process. Okay. So, it represents the total useful energy of a substance. So, formula ng ating enthalpy is internal energy plus the product of pressure and volume. Okay? So, kung si internal energy ay constant pressure process, okay, tandaan nyo no. So, the transferred heat energy transferred to a substance at a constant pressure process. Si internal energy naman, madadaanan natin siya. Madalas siyang ginagamit sa constant volume process. Ayan. Okay. So, malagay yung formulang yan. Kailangan natin siyang i-recall. Tandaan natin yan. Next, yan. The laws of thermodynamics. So, the first law of thermo is what we call the law of conservation of energy. Ang sabi dito, energy cannot be created nor be destroyed. It can only be transformed from one form to another. Or sa makatuwid, it is the sum of energy entering which is equal to the sum of energy leaving. So, tatanda lang natin itong mga nandito mga variables sa input side ay dapat equal siya sa mga variables dito sa output side. So, kung gagawa tayo ng equation dyan, so, we have, sa input side, we have the heat added to the system. So, kapag heat added, that is positive. Tapos kapag naman heat loss, that is negative, no? So positive Q, heat added. negative Q heat loss or subtracted. Ayan. Then, tuloy lang tayo. We have the potential energy 1, which is, nakadepende po siya sa altitude, mgh, plus kinetic energy 1, nakadepende naman to sa velocity, plus h1. Ano yung h natin? Tawag natin sa kanya ay enthalpy. So, may enthalpy tayo. Pag minsan walang given na h, internal energy naman, tsaka product ng pressure and volume. So, pwede pong hindi h, pwedeng u plus pv. Equal siya sa output part natin, which is, syempre may work. Okay? So, mamaya natin. Burahin mo natin. So, unahin natin si we have potential energy at point 2 at the output plus kinetic energy at the output plus enthalpy. Oops. Ayan. So, H2 plus work. So, si work naman, meron din siya positive at saka negative. Pag positive work done by the system. Work done by the system. So, ibig sabihin, ang nag-produce ay yung system. Pag negative work done to the system. Ibig sabihin, para gumana yung system, ay meron pang ginawang additional work. Kaya work done to the system, yung negative work. Okay? So, yan po yung kailangan nating tandaan. So, game! Try natin magsagot ng number 14. Okay, a steam turbine receives 1,630 kg of steam per hour at 340 meters per second velocity and 3,550 kJ per kilogram enthalpy. The steam leaves at 259 meters per second and 3,020 kJ per kilogram. Which of the following both nearly equals the power output? Ayan. So, this time, hinahanap po si power output natin. Okay. So, sir, paano yan? Power output yung hinahanap. Di ba, dapat work, no? So, kung i-analyze natin yung given, we have here the, ayan. So, we have, pinay natin color. We have mass. Oo. Pero dito, naka mass flow rate. Kasi per hour. No? So, mass flow rate yung meron tayo. So, we have, 1,630 kilogram per hour. And then, meron tayo dito binigay na velocity 1, which is 340 meters per second. And meron tayo ditong enthalpy 1 na naka kilojoule per kilogram. So, hindi actually, hindi kilojoule lang dapat siya, di ba? Pero naka per kilogram yung ating H1. So, dito, kailangan lang tayo mag-manipulate ng mga units, no? Para tumama yung magiging sagot natin sa huli. No? So, we have V2, which is 259 meters per second. Meron tayong H2, which is 3,020 kilojoule per kilogram. Ayan. Ang tanong, ano daw yung output power? So, yung output power kasi manggagaling dun sa output work. No? So, ibig sabihin kasi, di ba power is just work all over time. So, makapansin natin, meron per hour. So, dyan talaga manggagaling yung ating output power. Okay? So, sige lang, try nating i-manipulate kung mapapalabas ba natin na puro na instead of joules yung magiging mga unit ng ating mga uh, enthalpy, kinetic energy. Try natin dapat maging at least power bawat isa. So, game, try natin. So, ano ba yung formula na kailangan nating gamitin? Siyempre, yung first law of thermodynamics, no? Heat entering is equal to leaving. Okay? So, game, we have Q is equal to Q plus potential energy 1 plus kinetic energy 1 plus enthalpy 1 equals potential energy at point 2 plus kinetic energy at point 2 plus enthalpy at point 2 plus work. So, makapansin natin po, wala naman tayo dyang binigay na altitude, no, na height. So, we can cancel potential energies. So, meron tayo dyang velocity. That's why we can have the kinetic energy of both sides. Meron tayo dyang enthalpy, parehas. Pero wala naman sinabi na heat added or rejected or lost. So, we can cancel Q. So, bottom line, i-adjust natin. We have work is equal to KE1 minus KE2 plus H1 minus H2. Okay. Kaya nga lang, power yung papalabasin natin. So, in terms of watts yan. Okay? Ayan. So, ito. So, P is equal to ano ba yung kinetic energy natin? Di ba? 1/2 mv squared. Okay. Kaya nga lang, yung natin is mass flow rate, no? Ang given. So, naka per hour siya. So, ang gawin natin, convert na lang muna natin yung yung M natin into kilogram per second. No? So, pag ginawa natin yon, M is equal to 1630 kilogram per hour times 1 hour 3,600 seconds. So, ano sagot natin dyan? We have sige, pindutin natin sa calculator 1630 over 3,600. So we have 0.4528. 0.4528 kilogram per second. So yan. So game, gamitin natin. We have dalawang kinetic energy, 1/2 0.4528 kilogram per second. Tapos, syempre, pwede natin sabihin, V1 squared minus V2 squared. So, V1 squared natin is 340. Okay na yan, naka meters per second na, no? Minus 259. Plus H1 minus H2. So, ano yung H1 natin? We have, kilojoule per kilogram. So, ilipat na lang natin dito sa baba. So, plus, burahin ko lang ito. Okay. And, ano yung H1? 3,550. So, ang goal natin maging power yung ano, maging watts yung unit niya. Pero sir, naka-kilojoule per kilogram. Paano magiging watts yan? Ayun, di ba meron tayong factor na kilogram per second? Pag minultiply natin yan doon sa ating enthalpy, makakansel yung kilogram na magiging kilojoule per second. That is kilowatts. Tama ba? Yes, sir. So, yun po, So, gagawin lang natin, multiply lang natin ng 0.4528 kg per second. Cancel si kilogram. Meron tayong kilojoule per second or kilowatts. The same din yung gagawin natin doon sa kabila, sa H2. We have 3,020 kilojoule per kilogram times 0.4528 kilogram per second. Cancel si kilogram. Yan. Ayun. So, pwede na natin siyang pindutin yung output power. So, ang output power natin is, sige nga, tayo natin. 3,550 times, 0.5 times 0.4528 times 340 square minus 259 square yan, plus 3,550 0.4528 minus 3,020 times 0.4528 equals, we have, sir, ano nangyari? Ay, naka-kilojoules nga pala yan, guys. I'm sorry. So, we have, yan. So, dapat makita natin yung mga ganung bagay. Equals, ayan. So, we have 250, 968.7016 or pag inayos natin yan, we have 250.97 kilowatts. So, we have 250.97 kilowatts. So, again, ano po yun? Pinakamalapit na sagot natin, syempre, ay letter B. Okay? So, ganun lang po, kailangan nating mag-adjust sa hinihingi. So, this time, power kasi siya. So, we adjust the units into the desired output. Okay? Ayan. Okay. Let's proceed. Ayan. So, tapos tayo sa first law of thermodynamics. Punta tayo sa sa second law of thermo. So, dito meron tayong tatlong statement ni second law of thermodynamics. The first statement is the Clausius statement. It is applied for heat pump. And sabi dito, heat energy flows spontaneously from hot body to cold body. Lagi nating tatandaan, ang heat po ay nagfo-flow from hot to cold. Para siyang halimbawa, voltage. Ang current nagfo-flow from the point with the higher potential to the point with lower potential. Okay? So, same with with heat. Nagfo-flow siya from hot to cold. So, hindi natin pwedeng sabihin na, for example, sabi lagi, sarado mo yung pinto. Lumalabas ang lamig, di ba? Hindi po tama yung statement na yon. Bakit? Kasi hindi naman po na nangyayari na from cold to hot yung transfer. So, much better, na sabihin na, sarado mo yung pinto. Pumapasok ang init. Yon. Di ba? Sabihin natin, heat flows from hot to cold. Okay? Ayan. At mas mali naman sabihin na sarado mo yung pinto. Lalabas ang aircon.
Sa classroom may batas. Bawal lumabas o bawal lumabas.
Di ba? Yun. Mas mali yun. Siyempre, paano naman lumalabas yung aircon? Wala namang paa yun. Alright. Ayan. Okay. So, yun po. Yun po yung nangyayari from hot to cold. And then we have the Kelvin Planck statement for heat engine. Sabi dito, no heat engine that cycle continuously can change all its input energy to useful work. So, wala daw makakapag convert ng 100% efficiency. No. Lagi na lagi na meron pong matatapon, lagi na merong masasayang. Okay? The law of conservation of increased entropy, the third statement of our second law of thermodynamics. Ang sabi dito, if system undergoes spontaneous change, its entropy will increase or at best remain constant. So, entropy kasi yan eh. Yun yung disorder, o yung kaguluhan. So, sabi dito, kapag daw may nangyayari sa isang system, yung disorder sa system ay lagi siyang nag-i-increase. Or ang the best na pwedeng mangyari is nagiging constant lang yung yung disorderliness. Okay? Halimbawa, tayo ay nasa isang universe, nasa isang system tayo which is the universe. Okay? So halimbawa, naglinis ka ng bahay. So sa paglilinis mo ng bahay, nagwalis ka, So, sir, paano yun? Hindi naman naging disorder. Hindi naman ako nagdagdag ng disorder sa bahay ko kasi lalo nga naging maayos lalong luminis. Pero sa pag-aayos mo ng bahay mo, nagdagdag ka ng disorder sa kapaligiran mo. Siyempre, yung gabok, nilabas mo, 'di ba? So nagkameron ng disorder sa outside ng iyong bahay. And it counts for the disorder in the as a whole in the universe. So, nangyayari, kapag tayo may ginagawa tayo, nakakadagdag tayo sa disorder ng kabuuan. So, it's either the best lang is sa paggalaw natin ay walang nangyayari, walang nadadagdag ng disorder. Yun yung best. Pero hindi po pwedeng nababawasan yung entropy sa universe. Okay? So, yun po. Next, the third law of thermodynamics or the law of absolute entropy or Nernst law. And sabi dito, the total entropy of pure substances approaches zero as absolute thermodynamic temperature approaches zero. Ayan. So, nag-iingay si Sam. Gising pa siyang mga ganitong panahon. Oo. Okay. So, tatandaan, tawag dyan is the Nernst law. No. Ang atin daw total entropy ay nag-a-approach sa zero habang daw ang temperature ay nag-a-approach sa zero. No. So as temperature approaches zero. Yan. Okay. So, next tayo. Yan. The zeroth law of thermodynamics. Oops, sir! So, meron tayong first law, second law, and third law. Tapos ngayon, meron tayong zeroth law. Okay? And sabi dito sa zeroth law, when any two bodies are in thermal equilibrium with the third body, they are in thermal equilibrium with each other. So, sir, paano yun? Bakit may zeroth law? No. Kasi, sa order ng pagkaka-state o kaya pagkaka-invento ng statement is nauna yung mga first law, second law, and third law. And then here comes the another law of thermodynamics. So since this law is more more basic o kaya mas foundation siya na dapat mauna kaysa sa first law. hindi na lang nila binago yung first law, second law, o third law. Kasi, ano siya, nakasulat na sa libro, parang ganun, di ba? Para mababago ulit. So, instead of doing that, since mas fundamental to, ginawa nilang mas una sa first law, which is the zeroth law. Ayun. So, ito, no. Sabi dyan, kapag daw ang dalawang body ay in thermal equilibrium with each other, no, what do you mean by thermal equilibrium? So, sila ay thermal contact, magkadikit. No, halimbawa, meron tayo ditong dalawang body. Ito, mas mataas. Halimbawa, T hot. Ito, mas malamig. So, pag daw sila in thermal contact with each other, ang mangyayari, darating sa point, na yung TH natin ay magiging equal dun sa ating TC. Yan. So, darating sa point na sila ay magpaparehas. Darating yung time na yun. So, ayan. Ang tawag doon is the thermal equilibrium. Siyempre, yung mas mainit, siya yung maglulos ng heat. Yung mas malamig, siya yung mag-gain ng heat. And the third body is usually a thermometer. Siyempre, para malaman natin yung temperature ng first and second body. Okay, let's do this. Application ng ating zeroth law of thermodynamics is the calorimetry. And this is one of the topics in a board exam na lagi lumalabas with regards sa ating thermodynamics, the calorimetry problem. And sabi dito, calorimetry is an experimental technique used to measure the specific heat of a substance. Calorimetry measurements are made using a device called calorimeter. So, pakita ko lang po ang ang structure ni calorimeter. So, actually cup lang siya. So, meron siya ditong outer. No, it's a metal. Tapos meron pa ditong inner. Tapos meron ditong buffer na plastic. So, bali ito, yan? Air yan. Hangin lang yan. Bakit ganito yung structure ng calorimeter? It is because, nilelesen nito yung thermal contact. Nilelesen nito yung thermal contact para, para mabawasan yung heat transfer. Kasi kapag merong thermal contact, mas mabilis lalamig. Okay? So, ganito po yung structure ng ng ating thermos. No. So, kung di nyo po alam, yung thermos natin, na nilalagyan natin ng malamig na tubig or mainit na tubig, may space yan in between. No. So, to avoid too much transfer of heat, ganyan po yung structure niya. No. Okay. Yan. So, ito ang tatandaan natin sa calorimetry. Heat loss is equal to heat gain. At tatandaan, kapag heat loss, ito. Yan. Negative po lagi. No? At heat gain is positive. So, majority of the formula that we will use on this problem is MC delta T. Kasi involve si change in temperature. No. Kasi ang mangyayari dyan, ang naglolos ng heat ay lagi po yung mas mainit. Ang nagigain is yung mas malamig. Darating sa point na level na sila ng temperature. Ang tawag nga doon ay thermal equilibrium. Okay, let's proceed. Para mas magets natin. Game. If 80 grams of iron shot at 100 degrees Celsius is dropped into 200 grams of water at 20 degrees Celsius contained in an iron vessel of mass 50 grams, find the resulting temperature. The specific heat of iron is 0.16 calories per gram centigrade. Okay. So dito, alamin natin ano ba yung mga elements ng problem natin dito. So meron daw tayo ditong Mhm. Yan. Drawing natin. So, una, meron tayong 80 grams of iron shot. So, nilagay dito yung, yung mga iron shots. This is 80 grams. And then, meron tayo ditong, drop ito 200 grams of water. May tubig. Which is 200 grams. Ano pa? 20 degrees Celsius contained in an iron vessel of mass 50 grams. Yung lalagyan, ito, is 50 grams. So, tatlo yung element, no? No, iron shot, iron vessel, tsaka water. Ang tanong, find the resulting temperature. Find the final temperature ng tatlong to. Kasi darating nga yung point na sila ay magkakapare-parehas na ng temperature. Okay. Determine, alin muna yung nag-loss at alin yung nag-gain. So, loss. Base sa ating base sa, tong loss? Nawala. Heat loss. Aha. Base sa ating given, meron tayo 100 degrees Celsius na iron shot. Meron tayo ditong 20 degrees Celsius na water at saka iron vessel. Parehas ang temperature yung iron vessel. So definitely, since pinakamataas sa temperature si iron shot, no, yun yung magkakameron ng heat loss. Si iron shot. At ang mag-gain ng heat ay yung dalawa. Yung ating water at saka yung iron vessel. So, na-determine na natin. Gamitin natin yung ating formula. Game. So, we have heat loss, Q loss, is equal to Q gain. And this time, dalawa yung nag-gain, yung iron vessel at saka yung water. Take note, this should be negative. Game. So, we have negative MC delta T, mass ng ating iron shot. IS na lang. C ng ating iron. Delta T. We have delta T ng iron shot equals MC delta T ng water plus MC delta T ng iron vessel. Yan. So, pag inayos natin, pag pinasok natin yung mga given, we have mass ng iron shot, 80 grams. Take note, negative siya, no? C, ano yung C ng iron? 0.16 cal per GC. So, wala tayong problema sa, sa unit. Kasi, consistent naman sila. We have delta T. T2 minus T1. Final temperature minus the initial temperature. Alam natin, ang hinahanap natin dito is the resulting temperature or the final temperature. So, T2, yun, minus T1. Ano yung T1 natin? Yung initial temperature ng iron shot, which is 100 degrees Celsius. Equals, mass ng ating water, initially, that is 200 grams. Ano yung C ng water natin? Sir, walang given. Paano yan? Siyempre, dapat alam natin. Ano nga yan? We have 1 cal per GC. Then we have T2 minus T1. Ano yung final temperature? Siya yung hinahanap. Minus T1. Ano yung initial temperature ni water? Oo, tama. 20 degrees Celsius. Plus, MC delta T ni ni iron vessel. Ano yung mass ni iron vessel? We have 50 grams. C ni iron vessel, 0.16. Cal per GC. Delta T, T2 minus, same sila ng temperature na initial ni water. Ayan. And definitely, makukuha na natin si value ng T2. Pindutin natin. Negative 80 times 0.16 times x. We have x minus 100 equals 200 times 1 times x minus 20 plus 50 times 0.16 times x minus 20. Ang hirap pumindot. Shift solve. So, shift solve natin equals 24.64. Meron ba? Yes, sir! Meron! So, definitely 24.64 degrees Celsius. That is the final temperature, or we have letter B. Okay, guys? So, ayan. So, ganyan lang po pag-solve ng ating calorimetry problem. So, identify kung alin yung nag-loss, alin yung nag-gain. Laging tatandaan, negative po yung loss. Ito kasi madalas nawawala eh. Kasi akala nila loss na yan. Mali nga yun. Loss nga yun, loss. Lagi na lang loss, nawala. Though halos parehas lang naman siya. Okay, so that's it for our for this part of our lesson in thermodynamics. And I hope may natutunan tayo sa part na to. And thank you sa pakikinig. Again, see you sa next part ng ating lecture series ng thermodynamics. God bless, future engineers. Bam!